So welcome back guys. So today's GFG problem of the day is maximum of all subarrays of size k. It is rated medium. So let's see what the question states. But before moving on to the question, please subscribe to our channel. We solve GFG problem of the days and lead code daily challenges and all the contests solution of code forces, code chef and lead code you will get here. So let's move on to the question. The question states that we are given an array ARR of size n and an integer k. We have to find the maximum for each and every contiguous subarray of size k. Okay. So for example, if n is given 9 and k is given 3, so we have to a subarray. What is a subarray? It is uh, contiguous elements of an array. So here 1 2 3 is a subarray, and 2 3 1 is also a subarray, and 3 4 5 5 4 5 is also a subarray, but it is of size 4, so we are given size 3, so we can only take 3 1 and 4. Okay, so let's see. So like here the first contiguous subarray 1 2 3 has a maximum value 3, so our first max is 3. Similarly, when we traverse here 2 3 1, the max is 3, then we take 3. Similarly, when we go to 3 1 4, our max is 4, then we take 4, and we store it in a vector, and finally we return it. Okay, so for this question, I'll show you my brute force submission that will show TLE. So this is the brute force solution. Okay, so basically what we are doing is we are using sliding window, and for every element that we traverse, we go beyond 2 steps forward and check the maximum among them, and keep it in a vector, and finally we return our answer. So this is the big O n square solution. It will give a TLE in the 94th test case. So let's see which one is the correct summation. Okay, for the correct solution we use DQ. Okay, so for anyone who doesn't know what's a DQ, DQ is basically a queue which is like a doubly linked list. We can do all the operations like insertion and deletion from both the ends. Okay, so we can pop and push from both the ends. So we are using a DQ here. Okay, so for better understanding, let's understand the intuition first. uh, Here is the written intuition. Okay, first we maintain a DQ that I told already. So the intuition is we maintain the DQ in a decreasing order, so that the front of the DQ will always have the maximum value. That will be our answer for every window we traverse. Okay, so the front of the DQ will have the maximum value. So uh, we in a decreasing order, because any element less than equal to the current element should be removed, because that doesn't make any sense. We need a maximum one among them, so maximum should be on the first. Okay, so the time complexity will be let's forget time about time complexity for now. So the intuition is at any index, what we have to do with the DQ is at any index ARR of I, we have to check that if the DQ is out of bound, is there any element which is out of bound in the DQ, or anything less than equal to the current element that we are in, we should remove them, because anything less than equal to ARR 5 doesn't make any sense to be in the DQ. Okay, because we need the maximum element, so anything less than that we should remove them. Okay, so the front will be maximum always. So anything out of bound and anything less than ARR of I, we will remove them. Okay, so that's it. That's the intuition. So let's see how we can do this. So first we declare a DQ, then we have a vector as our answer. So then we traverse from 0 to the size of the array, or anything we are given vector. Then what we do is we first check for out of bounds. So if we have anything out of bound in the DQ, first we check if it is empty or not. Then we see if the DQ front double equals to I minus k. That means if we have to check up to here, then this will be the I minus kth index. So if it is there in the DQ, then we have to remove it. Okay, so we do simply DQ pop the front. Okay, we do pop the front. That means the out of bound indexes are removed from the DQ. We are storing indexes in the DQ basically. Okay, then we are removing the out of bound indexes here in this if statement. And then what we do is, then we will go on popping the DQ the elements which are lesser than the current element. Okay, so we see from the back DQ, if the DQ back is less than the current nums in element, then we just simply do DQ dot pop back. Okay, then finally what we do is we push the current index into the DQ. So if the index is greater than equal to k minus 1, that means we have we have our k value, that is the size of the sub array. Then what we do is anything at the front of the DQ, in this case the front should have been 3, okay, in the DQ. So anything in the front of the DQ is our answer. So 3 is pushed back into the answer vector. So similarly, we do this for the whole size n, and finally we return our answer. So let's submit it and see. Okay, I guess it's good to go. The similar question is a hard level question on LeetCode. That is sliding window maximum. It is the 239th question of LeetCode. So I have already submitted it. Okay, let's submit it again. Okay, so that's it for today. Thank you, and please don't forget to subscribe.